Hey everybody. Most people only see the final result, the moment when the website slows down, stops responding, or completely crashes. But behind every failure, there is a story, an application that is breaking inside, a server that is, refusing connection, a backend that is disappearing, or a system that is drowning under too much traffic. So in so inside the just a second, yeah. So inside the part one, so we understood why this happens, and today in part two we are going to go a bit deeper. So we are not going to imagine failures anymore. We are going to create them live. So hi, my name is Ashish, and in this video I'll take you through a real crash scenarios, 500 errors, connection refusals, timeouts, misconfigurations, high load failures, everything that breaks the server in the real world. So no theory, pure action. So, but before we also jump directly into this particular module, that is the hands-on module of server crash, we also understand like what we have seen in the previous video. So in the previous video, we understood that why server crashes under load using this simple analogy. Then we use the analogy of a restaurant, that how does a restaurant work and what will happen when there are more requests than the restaurant could cater. So that is similar what it happens in the in case of servers also, and mapping this to text. So we also understood like for example, if there are customers in a restaurant, that is equivalent to users to a server. Customers are making orders and the users are making requests. So this was the analogy that we discussed. And if you are deploying an application, we also understood like how to choose a server, what are the things that we should consider, like estimation of users, type of application that we are going to deploy, the request type, peak load planning, and everything. And once you have deployed the server, you also understood like how to check the server performance, the metrics like CPU, RAM, network, disk input, output, load average, and everything. And the metrics that we discussed just above, we have got certain tools that we can use to check. So for example, top, htop, free.m, netstat, everything is used to give us the details of the metrics that our server that how our server is performing. And we also understood some of the reasons why server could possibly crash. It could be either due to CPU exhaustion, memory exhaustion, too many connections, application bugs, traffic spikes, dependency failures, and all. Moving ahead, we also saw some of the common errors that I am very much sure that everybody must have come across. The errors could be 500 internal server error. So this error happens due to the application issue. Then there is service temporarily unavailable. So for example, the server is overloaded. For example, its capacity was 100 requests, but let's say there has been a traffic spike and the request has reached to 1000. So in that case, there will be service temporarily unavailable. Then there is gateway timeout. So here in gateway timeout, we also understood like, for example, if some or the other component of the application or the server or any of the dependency of the server, if they are not responding, then we get 500 for gateway timeout or bad gateway. And when server is not accepting connections, in that case also we happen to see an error, that is error is connection refused. And when the application has itself utilized or exhausted all the RAM that has been allocated, then the system kills that application. So these are some of the common errors that we have seen, and we have also seen how to debug the errors. Like for example, we have to check logs of the application and the system. They have to check the metrics, that is server performance metrics. Then you have to identify patterns, like is there any load, sudden spike and all. Then dependencies. Then we can also reproduce the issue and then we can apply the fix. So, but here in module 2, we are going to bring everything whatever we have discussed into action. So we are going to, I will not take much time on the theory since this is a performance or the implementation video. So what we are going to do, we are going to see all those errors. So what all errors we are going to see. So let us quickly see what all errors we are going to see. First error we are going to see is 500, that is internal server error. We would see that how do we get this error when there is a flaw in the application itself. Then there is a connection refused error, that for example, if the backend or if the server is not running and still the requests are trying to reach the server, then we get connection refused. Then we'll also see 503, which is gateway timeout. The one that I say that if any of the dependency of the application at the server level, hardware level, is not responding, then we get this gateway timeout error. Then there is also a 503. This is 504. I'm sorry. So and this 503 error is again when there is a high load on the server, and then we get this 503 error, that is timeout. Now what we are going to do in this we are again going to create we are going to deploy an EC2 instance. So we are going to deploy EC2 instance. We are going to install Docker. We are going to create a fast API application. We are going to create an image out of it, and we are going to run it as a container, run it as a container, and then perform various tests, and then perform various crash tests. We'll try to simulate how does actual crash happens. So without wasting much time on the theory part, let us quickly jump onto the AWS console. So we're going to write AWS Amazon, and we are going to quickly sign in. I'm going to deploy this again, FastAPI based application right from the scratch. So let us go to EC2 directly, and let us go to launch instance, and we are going to launch without a walkthrough, and let us name our application as Fast API Server Crash Demo. Okay, we are going to use the T2 Micro again, which is free tier, and it has got a very less server strength, one CPU, one virtual CPU, and 1 GB of memory, which is enough for us. We'll create a key pair. Let us create a key pair, for example, Fast API Server Crash Key. We are going to use .pem. RSA is the key pair type, and we are going to download it as a .pem format. And then we are going to download it, and we are going to keep all the other configurations default, and we'll launch the instance. So once it is getting launched, let us quickly go to our PEM file folder and drag and drop it to the desktop. Now, the moment when we drag and drop this particular key file, so we have to check its permissions first. So let me go to the terminal. Let me rearrange the windows over here. So let me go to the terminal over here. Now ls-lart, and let us see what is there. So fast API key is there, and it is got read and write. So anybody can write that particular or modify the hashes of that PEM file and can compromise our EC2 instance. So we have to change the permission. It has to be chmod 400. And what is the file name? Fast API key.pem. Now let us check again ls-lart, and we could see again it has got read permission. Perfect. Good for us. Now we'll directly go to the instance. So instance is in running state. Now quickly log into the instance. I have copied the public IP SSH-I, then our fast API PEM, then there is going to be EC2-user at the rate public IP. Yes, and we have logged in. Now quickly install Docker sudo yum install docker -y. So Docker gets installed over here, and then we'll start the Docker, and then we'll create our fast API application over here. So installation would take a little while. That is not a problem. So here again, I am deploying everything from scratch so that you stay connected with this entire demonstration. You do not feel very much aloof that you know where to begin or how to catch up, or if you want to replicate this scenario into your system, you can easily do that. So the command that I'm using there is on Mac, but you can find easily all the commands that you can use for your Windows system or maybe any other system that you are that will be using for this. So running the scriptlet and all, and we have to wait a little while till this gets installed successfully. Okay, this is taking a while. Verifying, done. So if you check docker hyphen version, let us see Docker is here. Perfect. Now sudo systemctl start Docker. Okay, so there is a spelling mistake over here. So we have to write sudo, not suso. Sudo, done. Let us check the status. status Docker is running. Perfect. Now we have to add our EC2 user into that group so that it does not so for example, why I'm saying this, if you type here sudo docker ps, you can run the docker commands, but if you directly type docker ps, it won't run. So here we have to add our EC2 user in that particular group so that it doesn't have to require sudo permission to run docker commands. So command is sudo sudo, then there is user mod, then there is AG, these are the flags, followed by Docker and our username, which is EC2 hyphen user. Okay, done. Now we have to quickly exit and re-log in. Exit. Now again we have to log in. So we have logged in. Let us check Docker PS. Perfect. So our user EC2 user is added into it. Now let us create a directory. Mkdir. No. Mkdir folder is app. CD into app. Now let us do nano main.py file. Here we'll be writing the code for our FastAPI application. So here is the code, and I'm going to paste this code in the comment section as well. So you can practice it from there. So this is there, Control X, Y, it has been saved, move a directory back, and then create a requirement.txt file. Requirements.txt. Done. So requirements are fast API and UVCon. UVCon. Now Control X, Y, done. Let us create a Docker file. Nano Docker file. Okay, so I have also got the Docker file handy with me. You can just use this particular Docker file. And I've also explained in my previous videos, if you just go and check out inside that DevOps project videos, the first one wherein I have created an application, on the EC2 instance, Dockerize it, and then access it over the public internet. So this is what I have done. You can do save it. Okay, okay. Let us see if our files are there. Cat Docker file, perfect. It is there. Cat app and then main.py. Okay, this is also there. And cat requirements.txt file, this is also there. Perfect. Now let us create the image. Docker build hyphen t. Image name should be fast API server crash image, followed by current directory. Now this image creation will take a while, and it will build all the the image building process happens in layers. So whatever we have described in the Docker file, if you say so, first it will be if that Docker container has got Python locally, then it will run it. Else it will pull Python from its hub. Then it is going to create a directory inside that container that is called as /app, and it will copy everything. Then using this command, it is going to install all the requirements, and then yes. So now it will take a while to install, and I think it is done. Let us check Docker images. Okay, images. Then now let us run the container. Docker run hyphen d is detached mode hyphen p, 8000 on the port, 8000 on the container, followed by name. Name should be fast API server crash container. What is the image name? Fast API server crash image img. Right? Let us see. It is created Docker PS. It is running. Now let us access it. So how we are going to access? We are going to use this public IP, and then we are going to type HTTP followed by public IP, and the port is 8000. Now question, would we be able to access this application? No. But now after making a small change, we will. So what is the problem over here? So if you go to security, we have not allowed port 8000 to receive any traffic on this EC2 instance. Currently it is only 22. So we are going to edit the inbound rules. And I'm going to add a rule. Let it be custom TCP. We have to configure port 8000, and it should be anywhere from IPv4, and we have to save the rule. So this is done, and now you see status is server is running. So our first error code, not exactly error code. So here, if we are able to access the application, here the service code or the status code is 200. Okay, now what we are going to do, we are going to do some failure. So let me go to error. So this is internal server error. Now let us check what this happened. So internal server error, what we see, what is this internal server error? So if you see 500 is the status code or the error code for internal server error. When this happens, when there is an issue with the application, issue with the application. So we have replicated that. So here if you see the error, it is internal server error. Now let us check what happened. So we'll go to Docker, we'll go to logs, and what is the container name? 8a. So, okay. Do you see here? 500 internal server error. What happened? It went to an exception. So we purposely, went to that particular route. Now, if I have to show you yes, do you see this particular code for fast API? Here it is like it is saying that when it is the default route, you have to say that server is running. But if you are going into this / error path, it is raising an exception. I mean, we are by default bugging our application, and it is going to internal server error with a status code of 500. So this is the first use case, or not exactly the use case, but the simulation of the error, that is 500. So when there is a problem with the application, we ourselves went into this exception state, and the application went into 500 internal server error. So this was the first demonstration. First demonstration states that we have got 500 internal server error. So we purposely broke our application, and we saw that we are getting an error which is called as 500 internal server error. Now let us go to second error replication. Now if we just remove this error over here and see application is again running. Now what we'll do, second, what is the second replication over here? Second replication is connection refuse. So when will a server refuse connection? So under what situation this server will refuse connection? When the server is down or inaccessible. In that case, whatever connection is coming down to us, it is going to refuse it, right? So we are going to stop this container and see what will happen. So we go here, and we see Docker PS. It is running Docker stop 8a. And now let us see what happens. See, error connection refused. So we successfully replicated our second error also, connection refused. So here in the first one there was a bug with the application. In the second one, the application or the server is in not running. So what is this? This is server not running at all. So that is why we are getting a connection refused. Now let us start the instance. Docker start. Okay, this is here. Now again we should be able to access the application. The request should reach out. See, again it is running. Now let us go to the third error. In the third error, what we are going to do, we are going to say service unavailable. So third error what we are going to do is service unavailable. So let us understand how we are going to do this service unavailable. 503 service unavailable. Okay, let us see what exactly we have to come down over here. So we have, so first scenario is done, internal server error. Second scenario is also done, connection refused. Third is we have to use a Nginx reverse proxy over here. So how we are going to do this Nginx reverse proxy? So we are going to install Nginx first. So let us go to the server, sudo yum install Nginx. Nginx-y. So I have created a couple of videos in which we have done some demonstrations on Nginx in the real-time environment. Nginx-v. Okay, Nginx is installed. So as I was saying that I have done a couple of videos on Nginx, wherein Nginx acts as a web server, Nginx acts as a reverse proxy, Nginx acts as a load balancer as well. So here we are going to use the feature of reverse proxy. So what exactly are we going to do? We are going to make some changes in the configuration file, and we are going to first remove the port. So let us open sudo nano etc. Okay, sudo nano etc nginx nginx.conf file. Okay, we went inside, and then do you see this first section inside the HTTP section? So here do you find this server? So it is saying that Nginx is listening on what server? Nginx is listening on port number 80. So you have to make some changes. What you have to make changes? We have to create a reverse proxy over here. So what do you have to do? You have to add this particular over here, right? Mm-hmm. Okay. So we have to add this over here. Now we have added this and let us correct the indentation. So here what we have to do, we have to correct the indentation. Okay, perfect. And here before breaking this, let us do one more thing. Okay, this is also correct. Now instead of routing it to port 9999, which does not exist, which we have not configured anywhere, let us route it to port 8000 first. Let us see that if the reverse proxy is working or not. I have posted it to 8000 and then we are also going to do this. Just a second, we are also going to make some configuration for the timeout, which we are going to use later. So what exactly we'll be doing? We will be making some changes. Okay, I think we have made the changes. Sleep, modify access, that is there. Mm-hmm. Yes. So we have to add proxy read timeout also. Okay. So let us add this timeout, proxy read timeout to 2. Going to add this over here. Okay, this is here. Okay, did we break something? Okay, that did not get copied. We have to again delete this. No problem. So what exactly are we going to put in over here? Proxy read timeout 2. Proxy read timeout 2. Okay, perfect. Control X, Y, save, got out. To see Nginx hyphen T. Okay, fail sudo Nginx hyphen T. It is working, test is successful now. Sudo systemctl start Nginx. Okay, restart Nginx. I think this will also work, but let us do restart also. Restart Nginx is done. So now we'll first let me help you understand what exactly we have done. So till now, how we were accessing our application, we were accessing our application using the HTTP. Then there was public IP of EC2 and followed by port that we have configured 8000. Now what we have done, we have so the request was coming directly to this particular location and it was okay, not this way. So the request, so whenever somebody was coming down to this particular location and it was getting routed to the application and then they could see the result. Now what we have created, we have installed Nginx and Nginx by default listens on port 80 and here in the backend we have mapped it to localhost to port 8000. So here instead of now this particular port without mentioning port, it should reach out to our application. So let us check now that whether this works or not. So if we are just removing this port, I think ideally it should work. Okay, let us go to security groups EC2. EC2 instance is running. Let us go inside the instance. Okay. Okay, connection timeout. Okay, is our application running? Let us see. Docker PS. It is running. Then still it is not. Okay, let us check the configuration file once again. Sudo nginx.conf. Okay. Okay, proxy read, proxy pass location. This is all correct. Let us retry. Sudo systemctl restart nginx. Okay. Now let us see once again if this works. Okay. So what could be the possible reason that it is not working? So our Nginx is listening on port 80. Let us see that if port 80 is allowed to receive traffic. Okay, so no, port 80 does not have the permission to receive traffic. So what we are going to do, we are going to edit the inbound rules. So quickly we are going to add a rule. It is going to be custom TCP. Let it this be port 80 and let this be custom anywhere and let us save the rule. And let us try again. See, it is running, right? So now, as we said that without even using the port, we are can directly access the application. So let's say you are going to public IP, then public IP, the request is getting public IP via port 80, and then it is routing the request to the local host at port 8000. So it is basically masking it. So localhost port 8000 and then we are able to access the application. So this is working. Now let's say port 8000 is pretty much configured. Now what if we mess up with the file and we change the port? We change the port from 8000 to 9000 wherein no application is running on this port 9000. Now let us see what will happen then. So what do? We just open this configuration file once again, nginx.conf, okay, and let us mess with the file. So where did we configure? Yeah, here it is. So let us change it to some other random port, which we have not, on that port nothing is running. So let us see in that case what is happening. 999999, right? X and Y and save, start, restart Nginx. Now let us see what will happen now. See, here we are getting an error. What is the error that we have got in the this particular case? Just a second. So what is the error that we have got when we are running on port 9999 is that service unavailable, right? So what does this service unavailable mean over here? So here, as we have, as I have already said, so this is the most common, production grade replication of the error, wherein the service is unavailable. So here, what it is happening? So your server is running, your application is running, but listening on port 8000, and by default, users are being routed to a different port where there is no one to receive, no server to cater the request. So that is why it says that service is unavailable. So here, what exactly I'm telling? I'm telling Nginx to forward the request to port 9999, but there is no application running on 9999. So this simulates a backend outrage. No application running on 9999. Now let us quickly change to the original port. So let us go here. Okay, let us come down. Okay. So here what I'm going to do, I am going to make it 8000. Again. So we replicated that issue, right? We understood that the server is running, but the application is routed to a different location where there is no one to receive the request. So hence there is the error service unavailable. That is 503 service unavailable. Now let us save it, Y, and let us restart. Restart Nginx. Okay, it is done. Now let us see. So it is running now. Perfect. So Nginx is working fine. Now we are going to see the fourth kind of error, that is error 504. So what we understood error 504. So 504 is if there is some or the other dependency of the server. Let's say some of the other dependency of the server which is not responding, then in that case it will enter into 504 error. So what I'm going to do here, so I have made a little changes over here. So what have I done? If you just look into my main.py file, app main.py file. Here, what I have done, I have defined a third function over here, which is called as slow. So what will happen? Anybody who will be entering this particular route slow, the function will respond after 10 seconds. And at the same time, if you see Nginx configuration file, if I go to this Nginx configuration file, here what I have done, so if you see it over here, here I've seen then proxy read timeout. That means the Nginx server will read the request, and if within 2 seconds, if it has not received the response, then it is going to, refuse the connection or refuse the request, and then it will show a gateway timeout error. So what we are going to do, we are going to just use this. We are going to route the path to slow. So slow is by default configured to respond after 10 seconds, but Nginx will wait only for 2 seconds. See, it is coming to an error. Wherein all the other path, if I directly go to default, it is running fine. But the only issue is with slow, right? It is only the issue is with slow. So we'll just save it. We'll come out Y and let us see. Okay, PS and then Docker logs 8A. Okay. Hmm. 404 not found, not found, not found status okay is here, right? So that is what exactly we mean by this particular error. Now we will do one final test, that is the load test. So in that load test, what exactly we are going to do? So we are going to, bombard. We are going to, do a simulation of bombarding the server with, multiple requests. Let's say 500 requests at a time and total of 10,000 requests, and let's see how their server performs. So what we are going to do, we are going to quickly install HTTPD tools over here. So this is the fifth simulation that we are going to do. So let us go to HTTPD sudo yum install HTTPD tools. So if we check now Apache benchmark -v, has this been installed? Perfect, it has been installed. Now what we are going to do, we are going to run this command. So this is our command. So here it is saying Apache benchmark. Total we have to send 20,000 requests. Now let us put a small number of requests first, and let's see how this is behaves. So let me put it only 1,000 requests and 100 requests at a time. To what location? So let us put the URL. What location? So this is going to be HTTP this, forward it to where location, what location? We'll put it to slow. Let us see. It is asking us to be patient, and in the meantime, it is going to complete the request. So this is working fine. But what if, so here the Nginx and the server, they are handling the request pretty much okay. Now let us bombard them with good number of requests. So let us put this, let me put this 50,000 requests. Huge, right? And let us put it 5,000 requests at a single time. 500 requests at a single time. Now let's see what happens. Is trying, so it is saying that connection reset by peer, exactly what we meant. So what is happening over here? So the request, let's say 500 request went to that particular server, and to that what function, to that slow function. So the server is supposed to take 10 seconds to respond, wherein Nginx has been configured to reject the connection if it is delayed by more than 2 seconds. So it has rejected all the connections, right? It has rejected all the connections, and that's why it is saying that connection reset by peer. So here what this means, here it the in the last demonstration, it means that there is a high load timeout failure, right? So we have overloaded the server with heavy traffic, and this is where the real world websites crash. So for example, if there is a sudden spike, let's say the we saw that whenever we were sending 100 requests or 200 requests, it was working fine, it was catering. But when there was a sudden spike, then the server could not cater all of the request, and it has rejected all the requests that was reaching out to be, saying that connection reset by peer. Only total of one request completed, because one request itself took much time and there was 500 in a bunch. So that is one of the beautiful use case that we can see why server crashes when there is a CPU hike. So what we have done, there is a small server, CPU has hit 100%, RAM gets full, and the server starts dropping the request. So this is what exactly we did. So we'll directly go back to the whiteboard. And so what we have done today, so here we have come down to the end of this particular video module. So here you have just watched a real server failure simulation, not just in textbook, not just in diagram, but right in front of you. We have done a lot of configurations, and then we have deliberately and purposely crashed the server in front of you. So 500 is when the, so what we have seen, 500 is the error when the app, there is an issue with the app, then it gets crashed. Connection refused is the second one that we saw. Connection refuse is the second one that we saw, which says that when server is down. 503 is the error that we saw when the backend disappeared. Remember, we configured 80 to port 8000, but we were routing it to port 9999. So here the server, here the application is running, but here nothing is running, right? So hence it was backend disappeared, and we saw an error 503. Now the next error was 504. 504 were when the backend was too slow to respond. Remember, we went to that slash slow route and we said that this particular function should respond in 10 seconds, but we have configured Nginx that if you don't get a response in 2 seconds, you drop down. And then last one we saw 503 error when there was a complete breakdown under high load. So what I feel, this is what engineers face every single day in production. And now you understand exactly how and why it happens. So if this helped you deepen your understanding, share it, support the channel, and stay tuned, because the next steps in DevOps and the backend engineering is only going to get more excited for you. So this was Ashish for you, signing off till the next video. Thank you for watching.